See what I mean about talking and doing at the same time? Okay. Given a point P, X, Y on a terminal arm, what chapter was this stuff? A couple ago. I think we called it 4. In standard position, why am I talking about this now? You will see. Okay, there's point P. To get there, I go some distance X and I go some distance Y. And let's call this a unit circle. I don't have to, but I can, so I will. Which means what? What's my radius of this circle? 1. Okay? So I do know x squared and y squared is 1 squared. Okay, and do we remember what x was? Like if I'm looking at x, I know the cosine, there's some angle theta, right? I didn't write it, is x over the hypotenuse, but in this case it's just a 1. So x is cosine theta. And y is, well, sorry, sine theta is y over 1. Okay? So if x is cosine theta and y is sine theta, then I can substitute those in there and go cosine of theta squared, or cosine squared theta plus sine squared theta is 1. There is a new trig identity. Okay? Feel free to put in degrees and prove it. It works. Other form, using tangent. I know this is true. Let's divide that by x squared. Both sides. That means every term. Not just one of the terms on the left side, every term. Okay? What's x squared divided by x squared? 1. This is y over x squared, and this is 1 over x squared. But as far as my unit circle goes here, what is y over x? Tangent. 1 plus tan squared of theta is, what's 1 over x? Well, what's x over 1? X over 1 is, no, it's a cosine. So what's 1 over x? What's 1 over cosine? Secant. Okay, here's a new identity. Cool, eh? Let's give you one more. X squared and y squared is 1 squared, which is 1. And, well, what haven't I done here yet? Let's divide both sides by y squared, which gives me x over y squared plus 1 is 1 over y squared. And I won't get you to do this on the test, okay? I'm just trying to show you where this stuff comes from instead of just, here it is, go with it, which sometimes I do. What's x over y? Well, what's y over x? Y over x is tangent, so x over y is cotangent. Plus 1 is 1 over y. Well, y over 1 is sine, so 1 over y is, what's 1 over sine? Cosecant squared theta. And some of you maybe cheated and went and looked right down there. Okay, so hey, 3 new identities to play with. And I don't, I don't do this every year. I've told you guys that. This one I got down pretty good. But these, I got to look, okay? I don't have them memorized, and you don't need to. I will give them to you. Okay, but you're going to have to refer back until they get familiar with you after you do, I don't know, a dozen or so of these. Then who knows? Maybe that will be something you memorize in your head. But still look and check, because I still see kids thinking they know it and they screw it up. Okay? So this, don't worry, these aren't anything new, but you know you can solve this thing for sine squared by subtracting cosine squared. And then you can solve this for cosine squared by subtracting sine squared, okay? Those are just derived from this. Same thing here, same thing there. Okay? So we're just going to see these three new ones today. Blah, blah, blah. All right, prove. It's telling you it's equal. You have to show me how we got there or why it is equal, okay? Can't just go, yes. I give you nothing for that. And show your work. This is a 3-mark question. You cannot prove it and still get 2 out of 3, maybe even 2.5 out of 3, okay? It'd be like me yesterday. I got it. I had it. It was there. It was on the tip of my tongue. I just swallowed it instead of saying it, okay? I was one little thing away. That would have been 2.5 out of 3, okay? So sine squared theta, well, let's just leave that one because I know I can do something with a cotangent. What's cotangent? Tangent sine over cosine, so cotangent is cosine over sine, which, hey, will get me to cancel something out. Right? Cos squared theta, by the way, that's all the left side. What can I do with 1 minus sine squared theta? Or am I done? I'm done. This is equal to that. That's one of my identities. Okay? So that is cos squared theta. Done. So only one step with that guy. That's a 1 marker. Okay, a little more involved. So, strategies. What can I do here? There's lots of squareds and minus ones. Do you remember seeing lots of that when we did factoring? When you have a difference of squares, doesn't it look like that? Is that like 4 minus x squared or x squared minus 9? This is like a difference of squares, isn't it? How do you get a difference of squares? By multiplying something with a conjugate, okay? That's on our little table yesterday of all the things we can do, including fractions and lowest common denominators, canceling stuff out. This is one of the things you want to think about. You see this and this? What happens if those were multiplied? That's something multiplied by its conjugate. I may end up with something that looks like that, a difference of squares. Okay? So that's where you want to look. Now, the process as to which you do this, there's a few options. So you may want to do this differently. But I want this to be my common denominator. So how do I do that? Remember me starting all this weird stuff? See, it's tough to visualize the good old grade 6 method when I do this. In order to get a 1 minus sign multiplied down here, I need to multiply it to the top. So here's one way to think about it. I'm going to multiply this guy by 1 minus sine theta over 1 minus sine theta, which is just 1. All right, I'm just multiplying it by 1. I'm not changing it. But when I get the denominator, it'll be both of these guys. And what can I do to this guy? I want to multiply it by 1 plus sine theta. Okay, so all of this is the left side. I'm going to obviously leave that one alone because it looks quite simplified. I want to get the left side to look like 2 secant theta. Okay? So, these are the same. So that is my common denominator. 1 minus sine theta, 1 plus sine theta. So up here, I'll do lots of steps, okay? That's what I got. Plus, I'll put the cosine out front, because that's usually how we want to look at distributive law. All I did was rewrite it. Okay, that's the same as this. That's the same as this. I just wrote it with the same common denominator, okay? I could have done 3 more steps with that, one little move. Of course, I'll run out of room. So what can I do here? I can multiply this stuff out. Maybe it'll become a little nicer. I can multiply the bottom out, which is, again, my strategy to start with, right? What's the bottom become? 1 plus sine theta minus sine theta. How many sine thetas do I have? Plus sine theta minus sine theta. They're gone. That's what always happens when you multiply something with its conjugate, right? I'm not going to write it. I said it. What's negative sine theta times positive sine theta? Minus sine squared theta. And that's something pretty, right? I just did this one. What do I have on the top? Cosine theta times 1 is cosine theta. Cos theta times negative sine theta is minus sine theta cos theta. Plus cos theta times 1 is plus cos theta. And cos theta times positive sine theta is plus sine theta cos theta. What can I do now? It is not stupid. It's the funnest thing you've done since 10 o'clock. Okay, focus. What can I do here? Like terms. How many sine theta cos thetas do I have? Negative 1 and plus 1. What's negative 1 plus 1? Thank you. Gone. Lovely. Cos theta and cos theta. How many cos thetas do I have? 1 and 1's 2. Yeah. 2 cos theta over. What's 1 minus sine squared theta? And it's going to take a while for you to realize that, hey, that's something I recognize. That's something nice. That is an identity. That's cos squared theta. Jesus is not going to help you. You don't have the faith. What can I do now? Get rid of 1 what? Yeah. We'll get rid of 1 cos theta. I got 1 on the top, I got 2 on the bottom, right? That's cos squared theta on the bottom. I'm going to cancel 1 of those suckers out. I got 2 over cos theta. That's about as nice as I could make that. What do I got over here? 2 secant theta, which is otherwise known as 2 times 1 over cos theta, or 2 over cos theta. Yippee-yi-yoo. Yes, yes it was. Okay. All right. Next one. Now which one do I going to work with here? Do I want to try to touch tan squared theta? No. That's nice and pretty. Leave them alone. Let's work with this side. What would my first step be? Foil it. Multiply it out. right? Unless that's an identity. Is that an identity? 1 minus cos squared theta? Oh, maybe I want to do that. Sine squared theta. What's 1 plus tan squared theta? Is that an identity? Let's have a look-see. And again, I don't have these memorized, guys. But I kind of like, I don't know. You just look. What's 1 plus tan squared theta? Secant squared theta. That's probably what you want to do first. You could multiply that out. It'd probably be a lot more work. What's sine squared theta? Sine squared theta. What's secant squared theta? 1 over cos squared theta. And what's sine divided by cosine? Tangent squared theta. That one was easy. Okay? Secant squared theta. Is that an identity? Let's have a look. Secant squared, hey, it's 1 plus tan squared theta. Cosecant, bet you that's something too. 1 plus cotangent squared theta. Now I know tangent, sine over cosine. Cotangent's the reciprocal of that. But I'm looking over here going, I don't see any sines and cosines, so maybe I'll just leave that. And I'll start working on the right side. That's the first thing I'm going to do. That is not tan squared theta plus cotangent squared theta, is it? It's tan theta plus cotan theta times itself. Make sure you get 4 terms here. Don't make that silly mistake that 80% of the population likes to do. Okay? So that's tan squared theta plus tan cotangent I'm going to run out of room. I'm going to skip my thetas. Tan cotangent. What do I got in the inside? Hey, the same thing. Tan cotangent. Last is cotangent squared of theta. I'm just dropping the theta, okay? What do I have, a square?
Never mind.
Got it? Yeah, tan times tan, tan squared, right? So, have a look at your left side. I got a tan squared, I got a tan squared. I got a cotangent squared, I got a cotangent squared. And what is tan times cotangent? Tan squared, that's sine over cosine. What's cotangent? Cosine over sine. Hey, what does that become? A 1. Guess what this one is? It's also a 1. So I'm done. Okay, left side looks like the right side. Not so bad. Only 2 lines of stuff. It's only a 2 marker. Okay? Questions? 2 more. Now I know it's tempting to think across multiplying. Do not. You can't. You're not allowed, right? What side do we want to work with here? They both look equally ugly, so it doesn't really matter, does it? Let's see what we can do with this. 1 minus cosine x over sine x Any hints? What should I do? Remember what I said before? I said lots of things, I know. We want to kind of get one of them, right? A difference of squares. You see, whoa, it froze. Come on. Got a virus scan going on. What could I multiply top and bottom by to maybe get a difference of squares? What's that C word I used before? Yeah, I use that one too. Conjugate. Okay, little hints I'm trying to say to you guys to try to know what to do first. Where do you start? Once I multiply that out, the middle terms cancel out because I'm multiplying something by its conjugate. I better bracket that so we're all happy. Okay, 1 plus minus junk. Junk cancels out. Negative cos squared x over sine x 1 plus cos x. Is that an identity? What is it? Yeah, that's sine squared x over sine x 1 plus cos x, which is what? Well, what can I do now? Cancel that one with that one, and what do I got? Bingo. Looks like the right side. I'm done. Okay, last one. Is there anything with a cubed in our identities? No, there is not. Sine squared times sine, that's sine cubed, isn't it? And I'm going to drop the x's just to save some efforts. But there is something with a squared, isn't there? I just wrote it. I want sine squared to be 1 minus cos squared. Anyone know why? Because when I factor it, I get a 1 plus a cosine, and that'll cancel that thingy on the bottom. 1 minus cos squared is 1 plus cos 1 minus cos. And bada bing, bada boom. That says cos. So that's about as nice as I could make the left side. Right side's kind of ugly. Let's play with it. Tan x. Do I want to make that sine over cosine? All over, what's secant? Secant's 1 over cosine. Anybody see something nice? You can get rid of cosine. Can I just get rid of cosine? Yeah, again, how do you think about that? Do you think to yourself, I am going to not divide by that, but multiply by that, so cosine divided by cosine's gone? Or do you just say to yourself, I want to multiply top and bottom by cosine, and it's still gone? Which way does your mind work? Hopefully one of the two ways. Okay, yeah, it doesn't matter. Cosine's gone. So what have I got left? Oh, hey, look. That's what I got over there, too. Yes, it is fun. It's like a game. It's like puzzles. We like to be challenged, right? So why you guys like driving? It's challenging. When you get to be my age, it's boring. Then you make your wife drive. I did tell you I used to go like 250 kilometers an hour, right? You think driving 110 down the highway is exciting now? Yeah. She refuses. But if it's a dangerous road or I'm feeling a little bit worried, then I'll take it.